Hi folks, welcome to another easy to follow maths video. Today's topic is tree diagrams and it's conditional probability. So these are often problems without replacement, i.e. you take an object from a bag, you observe its colour, say, but you don't replace it, and then you pick a second object from the bag. It's those types of problems that we're looking at today. Whenever we see a tree diagram, such as the one that's on the screen, which is for flicking two coins, so this would be here the first coin, and then these are the outcomes following on from a head with the first coin, and these are the outcomes which follow obtaining a tail with the first coin. So when we see a tree diagram that looks like this, those probabilities highlighted there are called conditional probabilities. This probability of 0.5 is on condition that the first coin you flicked was a head. Now, the second lot of probabilities that you can see highlighted are exactly the same as these probabilities here, because flicking a coin, the outcomes for the second coin do not depend on the outcomes for the first coin. So that's what we mean by independent. So these outcomes, or the probabilities of these outcomes, do not depend on what's happened previously. That's not always the case. So in this example, we've got a bag which contains yellow and blue balls, and we're going to take one ball out, and the key element of it is without replacement, a second ball is taken. So the probability of obtaining a yellow with our first pick is 6 out of 10 because there are 6 yellow balls, and altogether, because there are 6 yellow and 4 blue, there are 10 balls altogether, so that would be 6 out of 10. The probability of obtaining a blue ball with our first pick is 4 out of 10. Now, when we're choosing the second ball, remember we've already picked a ball out of the bag and we haven't replaced it. So now our probabilities don't stay the same. If we've picked a yellow with our first pick from the bag, then with our second pick, the probability of obtaining a yellow, all right, if we have a look at the diagram here, this was the bag where a yellow has been chosen first of all. So we can see left in the bag there are now 5 yellow balls left in and 4 blue balls. So there are 5 yellow balls out of a total of 9. And therefore, our probability of getting a yellow with a second ball is 5 out of 9. In the same way, the probability of choosing a blue ball, having previously selected a yellow, we look in the bag, there are 1, 2, 3, 4 blue balls left out of 9, so that gives us a probability of 4 out of 9. Now for the bottom branches, this is a probability of obtaining a yellow if the first ball chosen is a blue, as we can see over here. We've taken the blue out of the bag. So now, if we take the blue out of the bag, there are still 9 balls there altogether, but 6 of them are yellow. So now the probability of obtaining a yellow here is 6 out of 9. Note, these probabilities here have changed because they depend on whether we've picked a yellow one first or a blue ball first. Finally, on this slide, the probability of obtaining a blue ball after we've picked a blue ball first, remember we look over here, the blue balls is the one we've picked out of the bag. Now there are only 3 blue balls left. There are 9 altogether. So that's 3 out of 9. So I hope we can see now that these second lot of probabilities change depending on whether we've picked a yellow ball first or a blue ball first. That must mean that these probabilities are dependent on these first outcomes. So now if you want the probability of picking 2 yellow balls, that's that top outcome there, yellow followed by yellow, we multiply along the branches, and that gives us 30 out of 90, which is 1/3. Here again, we're looking at a second example, choosing balls from a bag, okay, without replacement. So there are 8 balls in the bag altogether, 5 red, 3 black. So that's 5 8s and 3 8s. That's okay, that's standard. But now when we're choosing our second ball, we have to be careful, have to do a little bit of thinking. The probability of a red with our second ball is dependent on what's occurred first. So here, this is the probability of a red given that the first ball we picked without replacement was a red. And that would be 4 out of 7, because if we've already picked a red, remember there were 5 to begin with, but if we've already picked a red out and we don't replace the ball, there are only 4 red balls left and 7 balls altogether, so that's 4 out of 7. Here, probability of picking out a black ball, remember there are only 7 balls left in the bag, but all 3 black balls are still in there. So this probability here will be 3 out of 7. Down here, 2 probabilities. Remember, this means we've taken a black ball to begin with, so there are only 7 balls left, and because the black one was the one that was taken, of those 7, 5 red ones are all in the bag still. So that gives us 5 out of 7 as a probability for the red. And then here, what's the probability with our second pick of choosing a black? Well, the first ball picked here has been black, so there are only 2 black balls left out of 7. So that probability is 2 out of 7. Now the question says find the probability of each colour. So that's a red followed by a black. And the probability of a red followed by a black, we multiply along the branches, 5 8 times 3 7ths, and that's 15 out of 56. But that's not the only way of obtaining a ball of each colour, because as well as getting a red followed by a black, we could have obtained a black followed by a red. And so we multiply along those 2 branches, the black branch followed by the red branch, and we get 15 out of 56 again. Now either of those 2 outcomes satisfy the event picking a ball of each colour. So we add the 2 probabilities together, and that gives us 15 out of 28. And that's the probability of picking a ball of each colour.